Hello, Algebra. Today we are going to be doing 4.5 notes, which is solving systems of linear inequality. To tell whether the ordered pair is a solution to the given system, we are going to substitute it into the first equation and the second equation to see if it's true. Before we just did linear inequalities and we would just put it into one. Now we'll put it into both. So if I know that this is my x and this is my y, then I'm going to try it into the first one. Y is less than or equal to x plus 2, while y is 5. So 5 should be less than or equal to x, which is 4, plus 2. 5 is less than or equal to 6. And is that true? Yes. I know that 4, 5 is a coordinate or is a solution to this part. So now let's check the next one. Let's check that in red. Y is greater than or equal to x minus 1. That's the second equation. Y again is 5. So 5 should be greater than or equal to 4 minus 1. 5 is greater than or equal to 3. Is that true? Yes. Because it's a solution to the first one in blue, and because it's a solution to the second one in red, I know, yes, 4, 5 is a solution to the system of inequalities, of linear inequalities. All right, now let's try out number 2. Again, here's your x and here's your y, because every coordinate comes with an x and a y. So I'm going to check the first one. Y is greater than 3x. So 3 should be greater than 3 times 1. 3 is greater than 3? No. If this was a greater than or equal to, it would work. But 3 is not bigger than 3. So no, it doesn't work. Now, if it doesn't work for the first system, for the first linear inequality, then I know it's not going to be a solution to the system. We could go ahead and try the second one all we want, and I'll do that with you, but it won't be a part for both of them. So y is less than x plus 2. Y again is 3. 3 is less than 1 plus 2. 3 is less than 3. No, that's not true. So this is not a solution to the system. That's how we can check algebraically. Go ahead and pause now, and I want you to try number 3. Pause and try out number 3. Right, so now you would have tested it, and yes, 2, 3 would be a solution to the system of linear inequality. So now let's learn how to graph those systems. We're going to graph just as we have before. We go one at a time. So I'm going to go ahead with the red one here. Y is greater than or equal to x plus 1. So my y-intercept on this is going to be 1, and my slope is going to be 1 over 1. So I know I'm going to start here. My y-intercept is at 1, and then my slope is 1 over 1. So I go up and right, up and right, up and right, up and right. If I can't go up and right, I'm going to go down and left. See that line that's forming? So now I need to think. This is a greater than or equal to. Remember, if it's less than or greater than, you have an open circle or a dashed line, an open line. If it's less than or equal to, greater than or equal to, you would have a closed circle or a solid line. So then here goes my solid line all the way through. And then because y is greater than that, I'm going to go ahead and shade above the line. So now we have that portion. Let's do the second equation. I'll do that one in blue. So I know that y is less than or equal to negative 2x. I know that the y-intercept is 0. Again, y equals mx plus b. And my slope is negative 2 over 1. I'm going to go down to right 1. So my start at 0, 0. I got to go down to right 1, down to right 1. If I can't go down and right, I can go up 2 and left 1. Up 2 and left 1. It's going to be good if you use two different colors so you can see exactly where it overlaps. So again, I look at my sign. This is less than or equal to, so I know there's going to be a solid line. And then because the y is less than or equal to negative 2x, I'm going to shade everywhere down below on that y line. So everything below the line goes. Now I should see that my solution is going to be over here in this region where the yellow or the blue and the red cross over. So down below here, we're going to go ahead and write A, 2 that are solutions, and then B, we're going to write 2 coordinates that are not solutions. All right, so for A, 2 solutions, I need to look over here in the yellow. Maybe I'll go here, 2, negative 3, or negative 3, 2. That's a solution. I could pick any 2, maybe negative 4 and 5 up here. That works. So negative 4 and 5. That's just 2 solution. 2 that would not be solution would be anything here in the red, because it wouldn't work for both, anything in the blue, or anything over here in the white area. So maybe I have 3, 1. That's not a solution. Or I could come down here in the blue, and I could get, what's that, negative 3, negative 4. Not a solution. We just have to know where those coordinates lie and where it would be a solution. All right, we're going to do number 5. Let's do that one together. We have here, I will do the top one in red again, just to be consistent. Here, my y-intercept is 4, and my slope is 2. I need a rise over run. So remember, that tells me if I go up or down, and then this bottom is going to tell me if I go right or left. It's positive, so it's up, and then that bottom one tells me to go right. So my y-intercept is going to be here at 4. And for the slope, I'm going to go up to, I can't even go up to. Well, if I can't go up and right, then I need to go down and left. So I'm going to go down 2, left 1, down 2, left 1, down 2, left 1. I see that my sign here says y is less than, so I know it's going to be an open line. Meaning, whatever it is, the point along this line is not a part of the solution. So y is less than this, less than, lower. It means I'm going to have everything lower, everything less, everything under that line. So I'm going to shade below. Less than, oh, let's put it over here. Less than, we shade below. See that W? Less and below. Greater than is going to go up, above. All right, so now let's look at the next line. We're going to do that one in blue. Y is greater than x minus 1. I'm going back to my bestie, which is slope-intercept form. I know my y-intercept is negative 1, and my slope is 1. So 1 over 1. I'm going to start first then at negative 1. I go up 1 and right 1. Up and right, up and right, up and right, up and right. Then I could go down and left, down and left, down and left, down and left. All right, so this is a greater than. I know I'm going to have a open line. And then it is greater than, so I'm going to shade above. This tells me that my solution to the system is going to be all the space in between the lines. And the solutions will be anything in here. So maybe 2, 3. I don't know. 0, 0 is also a solution. Not solutions would be anything here on the outskirts. So maybe 4, -4. And again, you can pick whatever you want as long as it's not in that yellow area. And then we have -4, 3. Those are all examples of non-solution. I want you to pause here and you are going to try number 6. All right, so now that you have worked on that one, we should see that we had parallel lines because those slopes were the same, but the y-intercepts were different. And your blue line should have had a y-intercept of 3, down 1, right 1, and it should be an open line. Your first line, which is red, should have a y-intercept of 0, down 1, right 1, and it should be an open line. And they were both shaded above because the y was greater. In that case, this yellow region is where they overlapped. 5, 5, 3, 4, that's mine. But you could have gotten any coordinate that's in this yellow area. Anything that would not be a solution would be anything else that's not in the yellow area. All right, so coming on down, we are going to be working with a word problem. Now remember, word problems give you specific limitations. So let's read. Lou is buying macaroni salad and potato salad for a picnic. Macaroni salad costs $4 per pound and potato salad costs $2 per pound. Lou would like to buy at least 6 pounds of salads and he wants to spend no more than $20. If he doesn't want to spend more than $20, then he wants to spend 20 or less. They tell me to let X be macaroni and Y be potato salad. So this is X and this is going to be Y. All right, so step 1, let's write the system of linear inequalities. Remember, money goes with money. This is correct. So macaroni salad is $4 and potato salad is $2. We're going to go with 4X for my macaroni plus 2Y, $2 for the potato, is no more than $20. So it has to be less than or equal to $20. Now, the next part of this, once I took care of the numbers for the money, it says Lou would like to buy 6 pounds of salad. Well, I don't know how many macaroni he's going to buy, and I don't know how many potato, but he needs at least 6 pounds. So if he has 5 pounds, that's not enough. At least 6 pounds means 6 pounds or more. So whatever he buys should be greater than or equal to 6 pounds. Now, part B says to graph the solution to the system. I can graph this in standard, but I do know that you like graphing it in slope-intercept form. So let's do it. We'll just have to change them around. So we have 4x plus 2y is less than or equal to 20. To get y by itself, I would minus 4x on both sides. Because I want y, I get rid of x. So that I get 2y is less than or equal to negative 4x plus 20. Then I can divide both sides by 2 so that y is less than or equal to negative 2x plus 10. That tells me that my slope is 10. No, I'm sorry, my y-intercept is 10. Whoa, 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 whoa. My y-intercept is 10 and my slope is negative 2. Negative 2 over 1 because I have to graph. Let's look at the next one. We could go ahead and do that one in blue. So we know that x plus y is greater than or equal to 6. So if I minus x on both sides, then y is greater than or equal to negative x plus 6. So my slope is negative 1, and my y-intercept is 6. All right, let's go ahead and graph them. I know that I need to get up to 10 on my y because my y-intercept is 10 up there. And then I could go on the bottom by ones. So let's do that. I'm going to go ahead and go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Here comes 0, 0. And this is a word problem talking about money and potatoes, so it won't go below. I can't have negative money and negative potatoes. All right. So this we have cost, and down here we have, oh, nope, they said X is the macaroni salad, macaroni, and Y is your potato salad. So that's potato. All right, let's graph this thing. So the first one in red says my y-intercept is going to be at 10, and then my slope is negative 2. So down 2, right 1, down 2, right 1, down 2, right 1, down 2, right 1, down 2, right 1. It is a less than or equal to sign, so I'm going to have a solid line. And then here it tells me that y is less than. So I'm going to shade below, less than, below. So there's my red. Now let me go ahead and I'm going to do the potato, or the next one, or second one. Y-intercept is at 6, and my slope is negative 1. So negative 1, down 1, right 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 1. And so this is my blue. It's going to be solid because the y is greater than or equal to. And since it's greater than, I'm going to go ahead and shade above. So this now tells me that right in here, this will be my my solution. The highlighted portion is my solution. That's where the blue and the red, they overlapped. All right. So I graphed the system. Part B is done. Now they're going to tell me all the possible combinations of pounds of potato salad and macaroni salad that I can buy. It's going to be important that you actually tell what it is. So let's say I have, maybe I want to come in here at 1.6, right? Then I need to say I can buy 1 pound macaroni and 6 pounds of potato salad. That's one. Another one I could do is if I want to get 2 pounds of macaroni. So I could go 2 pounds of macaroni. And if I do 2 pounds of macaroni, I could do 5 pounds of potato. Maybe I want to do no macaroni. I don't want any macaroni. Then I could maybe do 9 pounds of potato. 0 pounds of mac. 9 pounds potato. I'll do one more for the road. Maybe we want to do 1 pound of mac and 7 pounds of potato. That's possible too. 1 pound of mac and 7 pounds potato. It all depends on what you'd like to do. There's 2 combinations that he could not buy. Maybe he can't just go out there and buy 6 pounds of macaroni. Too much. He cannot do 6 pounds of mac and 0 pounds of potato. He cannot do 3 pound, 2 pounds of macaroni and 2 pounds of potato. Not enough. 2 pounds mac and 2 pounds potato. He can't do that because they needed at least 6 pounds. He won't have enough food for the people. So this is kind of how you can tell what you can buy and what you can't buy when you go to a store. All right. So this is it for systems of linear inequality. Please remember, in order to learn mathematics, you must actually do mathematics. Okay. Bye-bye.